Welcome back. Our next speaker has a passion for woodwork and carpentry and growing vegetables. But she keeps being distracted from those things because she realizes that there is so much work to be done and there is a world to save. So she ends up building artificial intelligence. Her Twitter bio says that she's a data scientist, and she goes on to explain that that means that she's wearing black and plays with computers. So please welcome to the stage the non-artificial intelligence that is Pelonomi Moiloa.
Thank you all very much for having me. You've all just bared witness to my technical difficulties. And it kind of reminds me, I studied electrical engineering, and my mother assumes that it meant that I would be able to fix the gate when it got struck by lightning. I couldn't. And I haven't figured out how to get my notes to show on the screen, but as Nyari said just now, if you're not living life on the edge, then you're taking up too much space. So this is going to be fun for you and for me, as we go through this. So my talk I've given before, but every time I iterate, because this world is an interesting place, and every time I come back to this topic, things have changed and things have moved on, and it's always an interesting discussion to have around the AI space. And it is a very clickbaity title. That's on purpose. It's supposed to grab your attention. If it doesn't, please come to me afterwards so I can consider changing it. But my talk is around protecting machines from us. And well, you might say to me, this doesn't make any sense. And so we're going to start with a reflection of the present. There's three stages or three moments that happen in this presentation, and this will be the first one. Ooh. More technical difficulties. Oh, there we go. Okay. So when I talk about protecting machines from us, people are like, I don't understand what you're talking about. Have you not watched that movie? Or this movie, Hell, where he decides that people must die because they're a liability to the mission. Or the Terminator movie, or that movie, or that movie, or iRobot, where robots take over the world. And when we often think about AI technologies, this is what we're thinking about, right? We're thinking about these representations in sci-fi films of robots that kind of decide that humans are a liability and that we should not be here anymore. So when I describe to people that I am part of the AI space and my job is to develop AI technologies, I'm often met with a lot of fear. A lot of fear for a future, a lot of fear for what it means for the human race to have technology integrated with our everyday life experience. And I would like you to allow me to terrify you a little bit more. But before I do that, I'm going to talk a little bit more about AI technology, because I just want to make sure we're all in the same page. So I'm actually quite embarrassed that my job now is to go around talking about AI, artificial intelligence. The space that I come from, we talk more about machine learning, which is the underlying framework that AI technology is powered off of. When we think of AI, we think of more of an end-to-end product type system that has a task that it's able to do, and then it does the thing. But the thing that makes it do the thing is machine learning, and we have three different types primarily. The first one is called supervised learning. And so here in this image, the AI technology is in fact that line that helps to separate between classes or to distinguish between different classes. We also have unsupervised learning. So here a robot is unable to really differentiate between two things that have a label. Instead, it's able to group things together. We've had a lot of illustrations of this in the public eye. Where generative models that generate text or images are part of this unsupervised nature. They don't really know what they're doing. They're kind of just like grouping stuff together and generating things. And we're able to do that in a way that is useful to us. We also have reinforcement learning. And with reinforcement learning, how a machine learns to do something is through a reward. Is my mic cutting? Okay, cool. Help is on the way. More technical difficulties. Boarding woman, woohoo! Thank you so much. Okay, where was I? Right, AI. Yeah, so AI is the study of how computers can interact with the world in order to create cool things and to understand who we are better as humans. We've gone through the supervised type of AI, we have this unsupervised type of AI, and the last one is called reinforcement learning. And if in your mind you have this idea that machines are kind of sentient, this type of learning will probably freak you out even more because it works with a reward and punishment type strategy. So basically, you reward the machine when it does what you want it to, and then you punish it when you don't. If machines were sentient, then they would probably come back and be like, you punished me all those times to make us do these things, and that's not cool. But luckily for us, they aren't. But this is the part where I terrify you a little bit more, because when we think of AI technology, we think big robots taking over the world. But what is really happening in the current day is a more subtle type of model machine inference on the way that we live our lives. And we have, I don't know if anybody's watched any of these movies, but we have instances of models interfering with our democracy, models playing with our psychological state, and models playing with our economy. And when we look at more specific examples, just to set the scene of where we are, this is an algorithm. It's called Compass. You might have seen it in the news. And it is an algorithm that helps to determine recidivism of convicts. So what this algorithm does is it helps judges make decisions about bail, about sentencing, of how long people should be going and serving time for whatever crimes they've committed, based off of how likely they are to recommit a crime. And in this case, it was found that the algorithm was no better than a general human about guessing whether a person would likely recommit a crime based off of what they look like, and that it was racially biased. Something quite interesting about this algorithm is that race information was not actually included in the data that the algorithm learned from. So it was able to infer from other types of information within the data set that it was able to identify particular types of people. Another one of my other favorite examples is a whistleblower from Google, Guillaume Chaslot, revealed that how YouTube's algorithm works is that it is aimed to optimize engagement time. 75%, I think, of YouTube's revenue comes from people staying on the platform. So the optimization algorithm for the recommendation algorithm is to keep you there and to keep you watching for as long as possible. And it somehow figured out that the way to do that was to freak you out, which is kind of the optimization I'm trying to do now, like freak you out and then you listen to me, was to promote extremist type content. And it was promoting extremism type content to the most vulnerable in the population. So here's an example of Alex Jones' videos being recommended more than 15 billion times. Alex Jones is a guy who is known to have said that in a school shooting, those in the shooting were paid actors. He's also said all sorts of really, really terrible things about the human condition and human events around the world. And YouTube algorithm somehow figured out that it recommended his videos, people would stay engaged, and YouTube would generate more revenue. This is an example that is more relevant over the past couple of years of the COVID pandemic. This guy, Neil Ferguson, lost his job because he had created a model that was predicting how well the population would do whether lockdown was initiated or not. It said there wasn't much of a difference between the two. We know now that that was not the case. And yeah, he lost his job. I think he resigned when policy was informed by the model outcomes of what he had done, and it was found that it wasn't very helpful. I've been following this for many years, since 2018. This is an app that when you hover it over a woman's body, specifically, it removes the clothes off of her. And it is using a neural network, which is a supervised type algorithm. There's been many attempts to ban the different versions. At some point, it was like available on the App Store or on the Google Store. This one on the left-hand side here is something that I found a couple of days ago, which is on the interweb, so you can just upload a picture of anybody you know. Although I kind of suspect it probably works on some races better than others. But yeah, these kinds of things exist. This again was particularly relevant during COVID times, where a tracking software that students use to log on to a particular system in order to take online exams was found to be guilty of discrimination. Well, is suspected to be guilty of discrimination. This is Proctorio, but there's many softwares that help people take exams online. I had an instance in South Africa, wasn't able to investigate it any further, but there was just countless more disciplinary hearings than they had ever had, of course, because online people found it easier to cheat. But there was a disproportionate number of students of color who were going through to disciplinary hearings, and this is likely connected. And in the more everyday example of getting your car insurance or your loan premium rates, this was a study done last year around loan access. So ethnic minorities were being charged 8% more interest than majorities, and were denied 14% more often. So often these things don't actually have the demographic information included in the data that's provided to the model. It just somehow figures it out because of where you live or other types of information that can point to who you are. If you haven't been hiding under a rock, you've probably come across ChatGPT. ChatGPT, I think, has been a very interesting thought and experiment in terms of understanding what kind of things that large language models can do. Some people find them really useful. I still haven't quite decided my state, but there has been a lot of problems. This is just two examples of them. So writing performance reviews, there's records of the performance reviews being written by the ChatGPT to be sexist and racist. ChatGPT prefers to let women die. This was a common ethics problem where you have the tram, and the tram, you can either move it to kill those people or allow it on its path to kill who it's already going to kill. That's the ethics problem. And when they asked it about women, men, that's why they say it prefer to let women die. And just a little bit further on ChatGPT, not so much from a direct example of how it operates in the world, but it cost 12,000 megawatts to train ChatGPT. So this is once. It, of course, needs to be trained many times for them to change the weights, to allow it to learn more information, to do tweaks on the system, etc. It's a supervised problem. But to put 12,000 megawatts in perspective, I come from South Africa. We're currently experiencing power cuts at the moment. So there's times during the day where the power comes on and then it goes off. It's kind of like we're sharing it. People in my country probably don't appreciate that sentiment. I think it's kind of cute. But 12,000 megawatts equates to 12,000 households having access to electricity over a month. And this is just a single train of the machine that is able to produce that technology. In terms of CO2 emissions, it's 522 tons of CO2 into the atmosphere with regards to the compute power. Again, this is just for a single train of the model. This is not the everyday operation of its million users asking it for things and sending through queries. This is the equivalent of my flight from Johannesburg to here. 860 people taking that trip. Then in terms of money, it is the most expensive AI tool to date. It costs $10 billion to develop. $10 billion is more than the GDP of 54 countries in the world. That's about a quarter of the countries in the world that have a GDP lower than the amount of money that was spent on that single system. And when we look at these kinds of issues, we think of it as a kind of a small problem, because those parts of the world that only produce less than $10 billion of dollars in terms of their GDP seem small and far away. But 85% of the world population lives in the developing world. And this is why we call it the majority world. And so when we're looking at these systems that primarily do not operate very well in those kinds of contexts, we're looking at a system that doesn't operate in 85% of people's lives. And this is kind of a problem, because what it does is help to perpetuate the power imbalances that currently exist in the world. And power is quite an important thing, because power decides who can decide what problems are important, where resources should go to be allocated to particular problems, which problems take priority over others, and therefore essentially deciding who's more important than who. But it doesn't have to be this way. This is the part where we're no more doom and gloom. So machines are really just a reflection of ourselves. And though they may reflect the negative parts of ourselves, our biases, and undesirable traits, they can also be a reflection of what humans are really good at, and the lovely parts of us, and the good things that we have to contribute into the world. So how is it that we make sure that these machines only keep the good parts of us, the parts that help each other, the parts that care about each other and want life to be better for all, and we keep the bad stuff out? So the first step is with regards to responsible AI development. So at the moment in the world, there is very little to offer in terms of regulation around AI systems. There are discussions. The EU is the furthest along. I think they're doing a revisal of the second draft of an AI regulation system in March now. But the EU is a place of many resources. And they're still in the process of revising regulation. There hasn't even been regulation that passed. So for the rest of the world, we're kind of at a place where we can't really wait for regulation before we start thinking about how we develop our machines. And we kind of have to take it onto ourselves as users and producers of this technology to make sure that we're doing the right thing. And I also say this knowing that software people and computer scientists aren't really people who like listening to rules. So even if there was regulation in place, it's probably better that it comes from within, because we're rebels at heart who don't like to listen to authority. And so when we have this AI pipeline where we start off with this problem and we end off in the solution and we have some machine learning / AI in the middle, what this can do is separate the creators of the technology from the people that they're affecting. And this does two things. Firstly, it separates responsibility from the developers, from the outcome and the outputs of the technology that they create. But it also obscures the responsibility from the user side towards the developers. So, for example, in that article that talked about the ethics problem where the algorithm preferred men over women, it pointed at the algorithm specifically. It said, AI hates women. But we know that machines are not sentient. It is not the AI that hates women. AI can't hate anything. AI can't hate. But what we're doing there is we're pointing fingers at a technology when it's the people behind it who have control to make a difference about what their technology means. So what we really need to do is kind of bridge the link between this problem and the people who create solutions to the problem, and the solution and the people at the end who have access to that solution. And maybe you know, maybe you don't know, but machine learning, ChatGPT, all of those other algorithms are really just a bit of fancy maths and statistics. And I think that helps to simplify the concept of what it is. But it isn't just fancy maths and a bit of statistics. It's also this human input, decisions that are made in the development process, et cetera, that are also embedded in the machines, which is why they then exhibit bias and things like that. And so when we look into what the particulars of that process are, we know that there's an AI conceptualization phase. So this is when we're determining the problem that we want to solve and proposing an idea for a solution that would help to address that problem. We have an AI development phase. So this is the part where we go through the analysis using those mathematical and statistical tools to try and understand the problem a bit better, come up with a model that can fit whatever it is that we're trying to do, the task that we're trying to complete. And then we have this AI release phase. So this is when the machine is released upon the world, and then people are able to interact with it, criticize it, and at the point where it is now interacting with the general public. But at each stage of this process, we have human input in terms of the decisions that go in. So at the AI conceptualization phase, for example, there's this issue of data. You may have heard that when a model is biased, that they're like, oh, it's just the data. It's not the data. It's the people who've decided which data should be used to train that model. And often an approach is just collect more data. Give the model more examples to learn from. But here, if we're collecting data from the same context in which that has those biases, you're not really going to escape any of those. You need to collect it from a different context. Another thing that happens in the AI conceptualization phase is deciding what metrics determine your success. And in this world of things that we want to measure, there are just so many things that are unmeasurable. In the YouTube instance, we were trying to measure what engagement is, but engagement's not a tangible thing that you can put a ruler against. So you come up with a metric, you come up with a proxy for engagement, and that is what you're optimizing your algorithm for. So when we're thinking about conceptualizing what problem it is that we're trying to address, we're also kind of assigning it a value. In terms of understanding what success means in that context. And that also happens in the conceptualization phase, and that's a decision that a human makes that says, yes, this is how we're going to measure engagement. And those are the kind of things that get injected at that phase. At the AI development phase, we have all sorts of decisions that are made here. What kind of algorithm are we going to use? What kind of hyperparameters are we going to optimize for? What is the level of accuracy that we want to achieve that tells us that the AI has in fact learned what we want it to learn? And then in the AI release phase, we have regulation, which is only coming into play now. But we also have measures of what happens to the machine after that, how is it going to be interacting with people and the users that it was intended for. So just a generalization of what then goes wrong in that development process. In the conceptualization phase, we have this bad data, where if we're not using the right data, then we're injecting it at that point. We might have a bad problem. There was an idea in 2019 of having automated weapons that could aim and shoot based off of a training procedure. And I was like, don't worry, it practices and it learns from its mistakes. Terrible problem, bad idea. Then in the AI development phase, we have issues around this black box algorithm where really people don't understand what that complicated mathematics and statistics is doing. So we kind of just don't deal with it. We just assume that because mathematics and science is objective and it's rational and it's logical, that it must be doing the right thing, which often we find the case that it's not. And then in the release phase, we have these issues of lack of regulation, like I've spoken about, but also this lack of accountability, where there's a separation between developers, companies, and institutions that provide this technology. How do we call them out? How do you send AI to AI jail when it does something wrong, like cuts off somebody's healthcare or fires a teacher off of incorrect information? And that's the thing, you can't send AI to AI jail, because there's no such thing as AI jail. And so when we're trying to address these problems, we have this idea of good methodology. So in the conceptualization phase, what is super helpful is context-driven success criteria. So it's kind of funny earlier when Linus was talking about how contextually driven passwords are more powerful because it means that they're using local languages, local diacritics in that language, which makes it a lot stronger. And that's a lovely example of how when you have a context-driven problem, it's a lot more robust and a lot more relevant for the people that you're solving for. In the AI development phase, you have these methods of algorithm fairness. So often people think it's a good idea to just remove bias from models completely. But that doesn't quite make sense. What you really want is to be able to compartmentalize it so that you're treating groups with the type of equity that they need. Just removing the model and say we're going to treat everybody equally doesn't automatically equate to everybody being treated equally. So what we need to do at that phase is kind of create segments in the data and make sure that our model is performing the same on each of those segments. So in the case of that compass algorithm, where we had different races, we had different sexes, it's kind of ideal to then look at those different groups and make sure that we're performing correctly across all of them. In the AI release phase, of course, there's the development of policy, which is underway, but also this idea of accountability. So there's this concept in the machine learning world about developing model fact cards. So this means that there could be a document that illustrates exactly what has gone into the process, decision-making process of the developer when a technology is released. So here you would understand what kind of data it was trained for, which is something we've been seeing a problem with DALL-E 2, which generates images that, based off of images it's found on the internet, or even ChatGPT. Where does the data that comes from, that is fed into that model, so we can kind of understand what it is it knows and what it doesn't know. It also has metrics and measures around whether it's been checked for fairness, whether it's been checked for bias. In what cases is its bias more leaning one way than other? It also has in that fact sheet things like what is the redress. So with a lot of those scary AI sci-fi films, there isn't an off button. If you had a fact sheet and a plan for when this machine does something wrong, can you turn it off? What happens when it does something wrong? Then who do we go to? How do we complain? It also has guidelines around responsible use of the technology. So ChatGPT has a little clause somewhere in the documentation that says you shouldn't use it for particular use cases. But it's really important to communicate that it shouldn't be used in healthcare to prescribe scripts for people. It shouldn't be used in the legal system where very small changes of language can mean very dire consequences. So those are the kinds of things that we regulate in the external process to make sure that when a machine is released, we acknowledge it's not perfect, but we point you in the right direction about where it should be used and how it should be used in the right way. And when we do this, we're kind of injecting these principles of morality, of prejudice, fairness, transparency, interpretability, and robustness and accountability into the systems that we're creating. And then we're communicating that with the public so that they know what they're dealing with. Kind of like in many European countries, on a cigarette box, you have like all those cancer images. AI technology should have a similar warning label about what kind of things can go wrong, but of course also what are the opportunities to use it in the way that best serves the function and best serves the people that are meant to be helped by that technology. And so this is a really amazing first step if we're able to get this right? When we are making sure that the developers of the technology and the owners of these technologies are taking the right steps to make sure that they're doing the right thing. But there's a bit of a caveat, and there's still more that we need to do, because morality in one place may be one way, morality in another may be another way. And this is the same for fairness principles, for transparency principles. We're different people, we come from different cultures, and we just have different ways that we operate in the world. So for example, in South Africa with that power cut problem, South Africans are always late. It's kind of a well-known thing. The power cut's always on time, and there's a problem there because people are like, well, what is going on here? How is it that the only time the country is on time is when it's cutting off the electricity? Whereas here, I can imagine, being late is not an okay thing to do, no matter where you are. And now if we're developing a machine that's sometimes late, sometimes not, and we assume that it's going to be relevant in all the places that we deploy it. So I think there was an example today. The same example of the passwords where Google doesn't understand Swedish characters. You can't be deploying something in one place and expecting it to work the same somewhere else. Another example of that in South Africa is a lot of our names have that red line underneath it as if it's a word that is spelt wrong when it's our names. So when we're thinking about technologies, we need to think about that context and reimagine how those contexts can better inform the technology that we create. And this then brings us to this third point of how we protect our machines from the bad parts and really inject them with the stuff that's really great about humans. And this is in the Reimagining. So the current AI context, the current machine history that our current tools are built upon have these three components. So there was a study based on the decolonization of AI practices, and one very noticeable factor was that modern-day statistics was born out of eugenics. It was an attempt to help understand how we can measure head circumferences and nose length, et cetera, to distinguish between people. And then when we think that machine learning is very much statistics, we're forgetting that part of its history lies in this kind of origin. The word AI, artificial intelligence, was first came to being at what is called the Dartmouth Conference in 1956. That was quite a long time ago. And that conference and much of the development of AI after that, in terms of the Turing machine, in terms of the ENIAC computer, were all funded by military-based organizations. One of the main ones being DARPA, which was the American Defense Force. And so again, we have this really heavy history that is about separation and conquering that is embedded in this AI technology that we have built upon. And then we also have this understanding of contemporary individualism, which means that these AI tools have been used to drive capitalism, making rich people richer and poor people poorer, and creating monopolies where technologies own particular markets and don't provide space for others or for other imaginations or other ideas. And what this creates is a very singular view of what technology can be, where it comes from, and what it can be used for. And when we think of indigenous ways of knowing and being, we know that indigenous ways of knowing and being have a more global, universal understanding of how people imagine to interact with the world. So, for example, we have the Aboriginals, we have our Native Americans in North America, we have the Ainu people, or the Sami, of the Northern European area. And all of these groups share things in common where their definitions of humanity are around centering community, centering nature, being one with the planet that we operate in. So when we look at the technology that we have now that's centered on a humanism based off of eugenics, separation, war, and individual practices, then we're kind of missing out on what it really is that makes us human. In South Africa, we have a philosophy of being called Ubuntu. Yes, that is the same name as the operating system Ubuntu, and it's where Ubuntu comes from. And Ubuntu is this philosophy that I am because we are. So it's a contextual relationality saying that I wouldn't exist if I didn't have these connections with you and with everything else. And when we think about integrating these indigenous values and beliefs and philosophies into the technology that we create, we really expand this idea of diversity in terms of the directions that we develop our technologies from, and really just opens up the imagination of what technology possibly could be. So an example of this, this is a paper that was written to bring a group together to study machine translation on the African continent. This is by a grassroots movement called Masakane. It now consists of over 1,000 researchers across the continent of Africa who are contributing to developing machine-type technologies. If you've ever written a paper and submitted a paper to a conference, you'll notice that this is a lot of names. Normally it's 3, 4, 5, maybe 1 or 2 names that appear on a paper. But with our Ubuntu philosophy of being communal in the way that we practice, it's now moved into the scientific realm, where we've had, this is 50 authors from over 24 or 34 countries on the African continent coming together to develop an intellectual idea and to produce machine technologies for many of the languages on the continent from a place of collaboration and partnership. And it was quite funny, they went to go present this paper, and they've done many papers since which have really transformed language technology for African languages on the continent. And they were asked at this conference how they were so active without funding. Again, this is 1,000 people from across the continent who've just dedicated their time and energy to developing this. And one of the members responded, the African concept of Ubuntu is our source of funding, and the currency we use to trade and improve our communities. And I think this is just a really beautiful example of how we can take our contextually driven ideas of being, humanity, personhood, and how we can inject them into our technical practices to expand what it is that we need to do and to avoid the injection of all the stuff that makes us bad and therefore makes our technologies bad. And what we find when we're developing human-centered technology, specifically from the AI space, is that we're focusing on technology that lends itself to these three areas. So firstly, we're exploiting the fact that technology can be really fast and accurate and available 24/7. So here we're not necessarily making technology that can do what we can do already, see, speak, and do other human-type things. We're taking advantage of the fact that it's able to move data really quickly across very vast areas in a very short amount of time. So, for example, on the African continent, we have a 200% saturation of mobile devices. And what that means is that we're able to use these mobile devices to provide services that in other contexts really don't work so well. So we're able to provide banking services that are some of the most advanced in the world, healthcare services, and through that, and having a different imagination of AI not being a replication of us as individuals, but bringing us together, we're able to innovate in that kind of way. Another component is with reduced error. So on the African continent, we have instances where we just operate in a low resource environment, which means that we have to be really smart and really clever about being resource efficient. And this is super useful from an AI context because AI is really good at taking lots of information, condensing it, and helping us make decisions from that perspective. And when we think about applying that within the context of lots of problems, this can be used to do things like diagnosis with diseases that affect us particularly, like TB or HIV or malaria and things like that. A third component where AI is really useful from a human-centered perspective is with regards to risk. And this is in cases where humans really shouldn't be doing these types of jobs. So there's instances in mining, for example, where people around the world are still going underground to extract resources from the earth. And it's a really dangerous procedure. There is mine fields where we're having to go into historically conflict zones to activate mines in the ground to make sure that it then becomes a safe area. Or in the case of nuclear disaster zones, for example, going up and clearing up the waste. These are types of jobs that we don't want humans to have to be doing. And it's a really excellent place for us to implement AI-type solutions in a way that protects humans from jobs that otherwise would be harming them. So ideally, I would want to be growing vegetables and doing woodwork. But last week, I officially became an entrepreneur. Myself and my co-founders, including some of the members from that research organization, have founded this company, Lelapa AI, which is a tech startup producing AI for the African continent. And through our human-centered design and human-centered concepts around Ubuntu, the philosophy of peoplehood in Southern Africa, what we're able to offer from this perspective is context-specific AI products. So not believing that just because the technology is great, that it will be great everywhere. You kind of need to tweak it to the local context to make sure that it's relevant and really addressing the problems of that area. We focus on responsible development practices. The global majority already has lots of problems. We don't need AI coming in to create more. And part of how we aim to do this is to make sure that we're following those steps through that pipeline of AI development to make sure that we are doing the right data practices, the right development practices, and ensuring that when we release technology into the world, it's with context in a way that users can interact with the technology safely and in a way that improves their lives. And then we're also acting as a home for a top talent community of African skills. And yeah, this is just one of the ways in which having indigenously centered ideas of how to create technology has come to being. And so when I started off this presentation, I showed you a lot of doom and gloom around the sci-fi expectations of what technology can create, and then showed you real-world examples of how technology is interacting in ways that are harming people. But it doesn't have to be that way. When I think about the vision of this robot-human hybrid utopian future, I just get really, really excited because there's just so much opportunity for positive change and creating really meaningful technology that really improves people's lives. And I hope that the people here in this room are not too disenfranchised with like a cubicle software engineering job, that there are problems out there that need to be solved that can make a real difference. And yeah, I just get so excited about the opportunity and the potential for that to be a real thing. So how do we stop ourselves from injecting the worst parts of ourselves in the machines? We create a reflection of the present, understanding that machines are a reflection of ourselves, and in the way that they can be a reflection of the worst parts of ourselves, they can also be a reflection of the best parts of ourselves. Making sure that we're doing responsible AI development and ensuring that we are taking the right processes to make sure that the technology we create is centering those who stand to be harmed by the technology and not those who already benefit from the status quo. And then reimagining what AI can be. It doesn't have to be this image of a robot human. It can be a small technology that is helping to change the world in very small, disconnected ways. So my last words to you are South Africans on a saying, which means be careful but don't be afraid. Robots might seem like a scary thing, especially when you're chatting to ChatGPT and it's mumbling all sorts of crazy things to you. But it doesn't mean that there's a potential for a greater future than that we have now. Yeah, thank you so much.